Assalamualaikum and good morning to our lecturer and all my friends. We are from Group 7. We'll present our group static project which is Fin Trust Bridge. First of all, I will introduce myself. My name is Muhammad Nuzakir Hadif bin Jonan. My matric number AA241415. Okay, we will look for our introduction for our study case. There are a lot of bridges around the world. Bridge that range is variety of form and special characteristic. Bridges are a system that is important in the assistance of movement throughout the world. Moreover, many different kind of truss bridge. The truss bridge is made of strength building material. This material have a hard resistance and less flexibility, and are connected together by a shape of angle that give the most hardness to the bridge. In order to test the strength and capacity of truss bridge, 4 different styles were selected and made through the Western Bridge Designer 2019 program. Each style selected and outlined below was used as an inspiration for the truss bridge design creator. After the assessment of comprehension and tension of each bridge, the design that will help the best and cost the less was selected for the remainder of the project. Okay, next for the background of study case. The Fin Truss Bridge was most popular throughout the 1950 and 1916 when the railroad industry was expanding across the country. The bridge architectural and structural design were created by civil engineer Albert Fink, as stated by Ken Fernald Smith in 1978. The bridge was originally built using iron material, mostly cast and wrought iron. This iron material were used routinely throughout Fink Truss Bridge until the mid 1870, when the most expensive material, which is steel, replaced them. It was discovered that bridges constructed of steel could tolerate more weight than those made of iron. Regardless of material, the Fin Truss Bridge remained one of the most innovative bridges of its time. There were 2 types of truss bridge Albert Fink designed, one of being the Fink Truss Bridge. The bridge had nearly all the supportive frame under the deck. The second type was the Fink Through Truss Bridge, which had its supportive frame vertically up from the deck. The second design was the most common during the 19th century.
Okay, so now I will be discussing about basic theory the Fin Truss, a highly efficient bridge design. So first thing first, this structure is known for its unique triangular framework, which excel in load distribution and stability. So how the Fin Truss works? The Fin Truss consists of interconnected triangular members designed to evenly distribute loads. Each panel shares the weight, reducing stress on individual components. So diagonal members handle tension, while horizontal ones manage compression, ensuring stability under heavy load. The advantage of the Fin Truss is its strength. It minimizes bending moments and material usage, reducing the risk of failure with even load distribution. No single member is overburdened, which increases durability and reliability. This design is particularly stable and prevents deformation. So the Fin Truss excel in handling concentrated loads such as dust from railway bridge and road bridge with heavy vehicles. Its lightweight yet strong design ensures economy efficiency, making it a preferred choice in engineering.
My name is Muhammad Adam Adham bin Burhanuddin. My matric number is AA241475. So I will continue my friend to present railroad engineering. The Fin Truss Bridge has found practically application in several types of railroad engineering projects, especially in the construction of highway, railway, combined and pedestrian bridge. For the first is highway bridge. Fin truss bridge were used extensively in the 19th and early 20th centuries for highway transportation. Number 2 is railway bridge. The Fin truss was particularly well suited for railway bridge, where long spans and heavy load from locomotive and train required a strong yet efficient design. Number 3 is combined bridge. Fin truss bridge were sometimes used as combined highway and railway bridge, especially in location where both type of traffic needed to cross the same waterway or valley. For the last is pedestrian bridge. Two less common than for highway or railway bridge, the fin truss has been used in the pedestrian bridge as well, particularly in urban or park areas where a relatively small span needed to bridge.
So now I would like to present the analysis and calculation. So this is the example of the fin thrust problems. Determine the forces in member BC, FC, and FG in the fin thrust below. So as you can see in here, this is the fin trusses. So I want to use the method of join. I probably have to start off with at A and work on my way towards the unknown bar forces. I recommend the method of section in these cases. In this case, because the method of section is more convenient if you don't need bar forces in every member. So first thing, I have to calculate. I have to calculate all the external reaction. So there's no horizontal loads on this, so obviously the is of x is zero is zero and a sub x is zero because there are no horizontal reaction. But I do have to find a sub y and the e sub y. Okay, now I pay attention to the geometry here. Notice that I have an angle alpha and angle beta. So this is the external reaction that I calculate. Like so, the sum of the moments about point A is zero. Okay, the sum of moment about the point A. Now this is the calculation. Now after that, we cut half of the fin thrust. As you can see here, the line AA, and we will get the free body diagram from that. And this is the wait, and this is the special triangles. Special triangles that we created to evaluate the trigonometric relationship that we are going to need later on. And this is the analysis calculation. We find the FFG, FFP, FBC, and FFC. After that, we find joint B using method of join. So you can see here, this is the free body diagram of it and the answer. And after that, we search for the joint F. So this is the free body diagram and the answer. So yeah, this is all the result. So that's all.
Okay, so now we will talk about the conclusion of this experiment. In conclusion, the static experiment on the fin thrust bridge demonstrates the effectiveness and efficiency of the fin thrust design in distributing loads and maintaining structural integrity under various static forces. Through the experiment, it was observed that the triangular configuration of the truss members allow for an even distribution of forces, with tension and compression forces being effectively transferred through the diagonal and vertical components of the truss. The result confirmed that the fin truss design is both material efficient and capable of handling significant static loads, which is why it was historically favoured for highway and railway bridge. Additionally, the experiment highlighted the importance of precise calculations and material choices in ensuring the stability. and safety of the structure, while the fin truss is less commonly used in the modern bridge construction due to investment in engineering and material. The experiment reinforced its historical relevance and its contribution to the development of efficient bridge design. Ultimately, the fin truss remains a solid example, a practical, cost-effective engineering that balances simplicity with strength, making it a valuable study for both historical and contemporary bridge design principles.